Okay, good morning class. So today we're looking at trig ratios. So you're looking at chapter 7, trig ratios. So we're going to go through the basics of trigonometry of grade 10. Okay, so in grade 10, the three trigonometric ratios, sine, cos and tan, where theta, sine, theta, cos theta and tan theta, where theta is an angle of any right angle triangle, were defined. For any right angle triangle, sine of theta is equal to opposite of hypotenuse, cos is adjacent of hypotenuse, and tan is opposite of adjacent. You guys remember it as Sokotawa, or Oliver has a hat of apples. Okay. So the following diagram illustrates these definitions. So if theta lies here, that is your opposite, that's your adjacent, that's your hypotenuse. If theta had lied here, that would have been your opposite, that would have been adjacent, this remains your hypotenuse. Your hypotenuse remains the hypotenuse. Okay. If theta lies here, that's your opposite, adjacent and hypotenuse. Okay. Then we know that sine theta, cos theta, tan theta is opposite of, okay, we spoke about that. Every alternative definitions is also, okay, so that's talking about x, y and r there. Okay, so the four quadrants, we know that is quadrant 1, 2 and 3 and 4, it will remain that labeling there as well. Also, we take it to a Cartesian plane, this is actually where x, y and r comes in. Every alternative definition also used in trigonometry ratios, the definitions are coming in. Okay, that is actually going into this here. Okay. Alright, also we know that if you draw your, we always work in the first quadrant, not so, even in this quadrant here, we need to complete this angle here. We always drop it onto the x, no? So that's your x and your y. Always drop it onto the x. This is your x and your y here. There. Always drop it onto the x. It will look like a bow tie afterwards. Okay. Not so. Always dropping it onto the x. Okay. Okay, that we know already. Okay. Also something else to consider is that in the first quadrant, your x is positive and your y is positive. Not so. If we look here, your x is positive and y is positive. If we draw in this quadrant here, what do you know about your x here? It's negative and your y is positive. Can you see that? Remember, r will always be positive. In that quadrant, what can we say? Both is negative. Not so. Both is negative. R remains positive, and here, x is positive and y is negative. Okay, just something to consider. We will be talking about that shortly as well. The summary of the signs of the ratios in all quadrants, as you can see here, in quadrant 1 all is positive, in quadrant 2 sine is positive and all others is negative, in quadrant 3 tan is positive and the other two is negative, in quadrant 4 cos is positive and all the others is negative. And that is how they come to the cos diagram. Here, all is positive. Here, sine is positive. Here, tan is positive. And here is cos positive. Can you see that, people? And that's what they call the cos diagram. The cos diagram. Okay. Or we can say it's the all stations to Claremont diagram. All stations to Claremont. Okay. You guys understand? Alright. But we'll speak again about that later. A brief overview of the general trigonometry covered in grade 10. So now in this period we're going to look at what you should have known at this point in grade 10. We're on which page are we on? (223). This example is on page 223. In which quadrant does x lie if tan is greater than 0 and cos is less than 0. People, does inequality mean to say greater than 0? What does greater than 0 mean? Tan is positive. Not so. And cos is less than 0. That means to say that cos is negative. Cos of theta is negative. Not so. So we draw in that quadrants now. This is all stations to them. So in which quadrants is tan positive? Tan is positive in quadrant 1 and quadrant 2. People, there will always be two quadrants where tan is positive and two quadrants where tan is negative. You guys understand? Then it says cos is negative. In which quadrants is cos negative? Quadrant 2 and quadrant 3. Can you see that? So, therefore, which quadrant would it be in? Therefore, the third quadrant. You guys understand? Let's look at the next example. The next example is on page 2, also 2 to 3. Here we are told if 13 cos alpha plus 5 is equal to 0. Okay? 13 cos alpha plus 5 is equal to 0. And sine is greater than 0. What does that mean to say? Sine is positive. Then which quadrant is sine positive? All stations to clear one. Quadrant 1 and 2. Determine what other is calculate the value of. Okay. So what we need to do is we need to make cos the subject of the formula. Cos alpha. We'll get the trigonometric ratio on its own. So how do I do that? Take the 5 over the equal sign becomes 13. Cos alpha is equal to negative 5. So what do I do now? You divide by 13 both sides. You want cos of alpha on its own. So in other words, cos of alpha is equal to negative 5 over 13. So what does this tell us? This tells us that cos is negative. Now moving too fast. No. Okay. So in which quadrant is cos negative? Second? Third. So which quadrant are we going to draw it in? Second quadrant. Why? Because it meets both conditions. Okay, so we draw in the second quadrant. So what does cos stand for? Adjacent over? Hypotenuse. So remember, hypotenuse is never negative. Not so? So what's the adjacent? Negative 5, which makes sense. Why? So it's on the negative part of your x-axis. You guys understand? And then how are we going to get this here? Pythagoras. So it's going to be 13 squared is equal to negative 5 squared plus your opposite side squared. And remember that is your alpha angle, okay? So that will be 169 minus 25. So your opposite works out to be 12, 144. Check. Yes. So you're going to give us 12. Is that 12 positive or negative? Positive. Why? Positive part of your y-axis. Can you see that? It's going to be 12. Now we can answer the question. The question says, must determine 13 sine alpha minus 5 tan alpha. Just put in a different color. 13 sine alpha minus 5 tan alpha. So you go 13. What does sine? Sine is opposite. It's 12 over 13 minus 5. Opposite 12 over negative 5. So that's simply going to give us 12 plus 12, which is any confusion at this point? No? This is a common asked question, so you must get this right. If you don't understand it, let me know. And then here, without the aid of a calculator, with the use of a calculator, determine the value of the following. So let's look at A. A, you've got sine squared 60 plus sine squared 30. Now we have three special angles, special triangles, okay? The one being 30, 60, 1, 2, square root. People, whenever you get a special angles trig question like this, what you do is you always draw this on the side, so that the examiner knows you know what you're doing. Okay? And then you got the isosceles triangle, which is 45. It's 1, 1 square root 2. And the third one is not a triangle, okay, but works for what we're looking at. Okay? If that is 90 and that is 90, which means to say there must be no angle here. That's why it's not a triangle. Okay? But like I said, it's working for what we are using it for. Okay, it always works. Okay, so let's see. So sine of 60. People, what is sine of 60? What does sine stand for? Opposite over? Opposite. So what's my opposite to 60? Square root of 3. So it's going to be square root of 3 over 2. And it must be squared. We see that, people? Plus 30. Sine of 30. It's going to be 1 over 2. And it must be squared. Okay. So that's 3 over 4 plus 1 over 4, which is 4 over 4, which is okay. Let's look at B. B, we got sine of 30, tan of 45, sine of 90 over cos of 60. Okay. Okay, so sine of 30, these are 30 degrees. What does sine stand for? Opposite over hypotenuse. So it's going to be 1 over 2 times. Tan of 45, here's your 45 degree angle. Tan is opposite over adjacent. So it's 1 over 1 times. Sine of 90. Here's 90. It's supposed to be a 1 here. No? What does sine stand for? Opposite over hypotenuse. Okay, that's all over. Cos of 60. Here's your 60 degree. Cos is adjacent over hypotenuse. Do you guys understand? So what's going to happen here? The halves cancel. This leaves us with. Okay. See, any confusion at this point? No. Okay, so I'm going to stop the video at this point. Alright? With that, you should be able to do exercise 7.1 on page 225. Also in the description box below, you'll find the link to the full lessons of last year. Yes? Put it, okay.